Hello everyone, welcome to the Esperanto job fair. My name is Raj Khanna. I'm Senior Director of VLSI at Esperanto. I and Udi Kalekin will tell you about the company. We're going to start with a bit of the background on the market we're in. It's actually a very exciting market, AI. We'll talk a little bit about that. And then I'm going to tell you a bit more about our hardware solution, how we're unique, and how it might be the right thing for you. And then Udi's going to come in and tell us about our very unique software solution, which goes along with the hardware to provide a total AI solution. There's been a lot of buzz recently about AI. It has been kind of an up-and-coming market, one of the really high-growth markets already. But as you know, there was an inflection point earlier this year. We don't have all the data on that yet, but even using last year's data, we believe it's a huge market with a really high growth, compounded annual growth of somewhere around 37% is what people were projecting even as of last year. So what does that actually mean? So we'll talk about that a little bit. But as someone who is looking to transform their career, I think this growth potential is actually something very significant. So if there's industry growth, there is very likely to be company growth. Company growth usually means organizational growth, and organizational growth is really what you want if you're looking for career growth. So I think looking for that really high growth in an industry where you add a lot of value is actually a really good fit. What it also means is that I think this area of AI will be with us for a very long time. And we're going to talk about all of the industry sectors that have already been transformed and more are being transformed. So I think there's career longevity here. And also, if you're someone like me who really enjoys tough, hard engineering problems and innovation, I think we're going to see a tremendous amount of that. There are so many people who are coming into this market with so many innovative ideas from all over the place that I think this is going to be a really great place to be if you're interested in that sort of innovation. So again, this is last year's data, and things have changed a lot. But even as of last year, there were entire industries that were being transformed. The first one there listed is healthcare. That's one that I'm actually very excited about. Right, there hasn't been a tremendous amount of innovation in some of these areas for a long time now. There's potential to completely transform. If you look at automotive, of course we've heard so many things about self-driving and how that will change things. But there are other areas where we probably hear less, but are also being transformed substantially. Right, law, especially now with legal co-pilots. Agriculture, retail, advertising, pretty much everything. To give you a flavor for what that 37% compound annual growth really means, if you look here at the chart on the right, we're here in 2022. That's the 136 billion or so market. In about 5 years, in 2028, we crossed the $1 trillion mark. Right. So to give you a flavor for what that really means, just last year, all of the semiconductor companies together, right, that include Samsung, Intel, AMD, Marvell, right, all of the semiconductor companies together had a revenue of somewhere around 700 billion. So in 5 years, AI is going to exceed substantially the entire semiconductor company total revenue. And so that's really substantial growth. And here are some examples, right? We've talked a little bit about the inflection point earlier this year that was caused by ChatGPT 3 and then 3.5 and 4, right? So that's one area of generative AI, right? AI is a very big space, and within that is generative AI. But within generative AI, there's not only text-based, but there is image, right? If any of you have had the opportunity to go, I'm sure all of you are pretty active probably with ChatGPT because it's been a very interesting thing to look at. But There are other things that are doing things like generating images, like this Dolly. I can actually go there and I can say, give me a flying pig, and it will actually generate a high-res image of a flying pig that you can't really tell whether it's a real photograph or not. People have done really amazing things. This was an interesting ad I was looking at. Balenciaga, that is, essentially generating these amazing, artwork, photographs, and even video clips. I saw a really interesting video clip of Lord of the Rings that was completely generated by some of these applications. So there's a lot of scope, a lot of ways to apply generative AI that are being done across the whole space. The interesting thing for us is that, we are hardware. We don't really care about the algorithms, and our hardware is actually very flexible, and I'll tell you in a little bit why that is. So we are actually able to, explore many of these areas, right? So we're kind of like, if you imagine that AI, and especially generative AI, is sort of the gold rush, we're kind of the shovel, right? We can be the guys who can support growth in any of these things as models change, as things grow, new applications come up. We can be, a part of a lot of the cross-section of what's going on. Okay, so getting into a company, what we do and what we're good at. Essentially, the number one thing that we have that I think we're really proud of is we have a great energy efficient solution. We'll talk about that a little bit, but that's been one of the things that's been really important in the AI hardware market, because there's such a huge performance requirement, such a huge computing requirement. To be able to fit that into something that's practical has been one of the quests of AI hardware. We also have an architecture that's actually very scalable. We can put many of our chips together and build systems that are very large, or we can build systems that are very small. We like to think of ourselves as an AI supercomputer on a chip with the number of cores and the amount of performance that we're actually able to deliver on a chip is actually pretty amazing. This would have been actually a supercomputer not too long ago. And we're also part of the RISC-V community. We use RISC-V cores, and so that's another really great trend that we're happy to be proud of, to be part of. So getting into what our chip is, what it does, and some of the characteristics. The first thing that's actually really shocking about it, when I first heard of Esperanto, that there were 1,000 cores on a single chip, I couldn't believe it. But we have over 1,000 RISC-V cores, and these are not tiny cores. These are actually 64-bit cores with wide vector units that are capable of running up to gigahertz sort of frequency. So very respectable cores. And we've managed to deliver those in tens of watts, right? Where, you may be used to seeing tens or hundreds of cores at hundreds of watts. We are actually delivering thousands of cores at tens of watts. So that's actually a really shocking amount of power efficiency that we're able to deliver in real products. So some of the other things, we also have our own high-performance out-of-order core. That's also a RISC-V core that's integrated into our solution. Currently we're in 7 nanometer, but looking to move forward to more advanced FinFET technology. And our approach is a little bit different than what you may see with other ML or AI chip approaches. So what other chips have done, right? As I mentioned, there's a quest to deliver a tremendous amount of performance for a very low power envelope. So a lot of the industry has moved towards very dedicated compute units, essentially accelerators that basically do one thing, right? And some of that has led to systolic array sort of designs, where essentially what it is basically a pipeline of computation where there are essentially lots of different compute sort of units, load stores and various kinds of adders and multipliers and so forth. So that's actually a way to get very good power efficiency, because we don't, those schemes don't implement a general architecture, right? The instruction set is very limited. The timing is very limited, so it's a good way to get efficiency, right? Throw a lot of hardware overboard and get power efficiency. But what we've done is we've actually implemented very high power efficiency using general purpose cores, right? So we've sort of put together kind of the best of both worlds, where you have programming flexibility, but you also have a tremendous amount of power efficiency. How did we manage to do all of that? How did we manage to squeeze 1,000 cores into that power envelope? Well, first of all, ground up, we have hundreds of very innovative low power techniques that we've developed. This is part of our innovation. Starting with the ISA, we start with a very simple ISA. We design our software, firmware, right, the algorithms we use, and so on and so forth, essentially ground up to be power efficient. Microarchitecture, obviously, even though we're using the standard ISA, there are lots of microarchitecture techniques, logic design, circuit design, library, and methodology. We innovate in all of these areas. We also have our own IP. I mentioned the Maxion, which is our out-of-order core. The Minion is our small core. We have our own NOCs. We do all of our verification in-house, and we have a very good collaboration between our software systems and the VLSI, so that we're able to innovate across all of these areas. Hand it off to Udi at this point, who's going to tell us more about the software side of the world.
Thanks, Raj. I'm Udi Kalikin. I'm a VP software here at Esperanto. Raj alluded to that a couple of times. What we have is really the power of Lilliputians. We have the flexibility and we have familiarity. We're dealing with a whole bunch of RISC-V, which are many-core architecture. They're little, but they're able, and it's generic RISC-V cores with some extensions that are necessary for our AI target, but that's not the only thing we can do. The notion is that we have many cores and we can connect it in a special way. We can retarget them relatively, I don't want to use the word easy, but straightforward, and using familiar tools to the changes in the AI world, but as well as any other HPC or any other market. So that provides flexibility that we're not doing anything weird, and we're using open source tools for the most part. It's future-proof insofar as we're using, again, the new algorithms like quote-unquote just software, using GCC or LLVM-based tools and open source tools for AI, etc. The actual execution platform is based, the software, the abstraction layer on both of this, on the host and the device side, are agnostic of how the code is generated. So it can be generated by just a straight-ahead C++ compiler or by an AI compiler that I'm going to talk about in a little bit. What we have here, the description here is really two stacks that we have. One is an ML SDK, and the other is a general purpose SDK that we have now. Actually, there's a third stack that I'm not having here that is really more utility, the device management to get information about it and control it, etc. Change temperature, frequency, performance of any kind of traces, etc. But that's not described here. But that's actually the fundamentals of the underpinning of everything that we execute on top. The ML stack is based on open source. Either you can feed it by PyTorch, or you can bring any Onyx. We use Onyx as an input from any frameworks that you have out there. So if you're coming from TensorFlow or older model Cafe 2 or anything else, that you convert it to Onyx and then being fed into our compiler. The framework is Go-based for some historical reasons, but that we're really not necessarily married to it because it's really just the front end, and all the gut and all the optimizations and really deep optimization that targeted at our execution model, execution platform is really done in something that is Esperanto specific. So it could be migrated to other frameworks as well. We can compile either, just in time, or we can do that ahead of time compilation. That's really a user choice, and that's really being fed into the runtime, into a runtime layer, both on the host side and the device side, and then executed by the minions on the ML side. If you look at the on the stack on the left, it's really all the difference, which is actually quite a bit of work on our part, but to make it so, but it's really accessible to the user, and it's basically C++ straight ahead, currently a GCC, but could be anything, and tool chain with some specialized Esperanto technology library, but then you see at the bottom left side of the stack looks exactly the same as the other one. So again, completely agnostic to how the code was generated, and it just goes down to the platform. We do have simulation, so you can see either we can execute on the silicon, or we can execute on the simulator. North of 95% of applications are null operator when we develop actually on a simulator. It's not an emulator. It's not cycle accurate, of course, but it's convenient enough. So for the most part, most of the bugs, anything that we develop new can be discovered there. And rarely do we have to go down into the silicon and debug it. However, we do have, I mentioned before, the device management stack that includes support for GDB, and so we can debug both, on silicon and on the simulator, and it pretty much the front end from what is exposed to the user is basically Linux shell that you can type commands into, bring your own model. I think we provide a whole bunch of models ourselves that we develop, that we optimize to our target, but there's also a mechanism to bring in your own model and run it, again, either on the simulator or on silicon. You can compare it to running on CPU in PyTorch, but so you can get some reference relative to what you'd expect. So it's both. Additionally, we also support PyTorch enhanced Jupyter Notebook, so you can actually, there's a path by which you can develop the application and then lower it to run it on the platform itself. Again, Raj mentioned we're part of the RISC-V, the RISC-V community, and quite active there. And yes, so the one thing I want to mention again, I hope it's obvious here, but again, the flexibility of many familiar little cores, gives us, is really very powerful. And we actually have full, I know that AI is sexy and we all like it, and generative AI is great, but it's not that the rest of the computing world disappeared, and we actually get pull from customers both on the AI side, on HPC, and potentially control code and automotive, etc. So this is it could be an interesting roadmap in various markets. Yeah. Okay. So I just wanted to give a general, on the software side, what we're looking for is really people that are specialized in the LLVM compiler. Some of the stuff that is specific, and some of it is interaction with the LLVM community. MLAI, currently at Globe, but there are other frameworks that we intend to be involved with. Against low-level system folks, Linux folks, DevOps, and software QA. These are the areas where we're looking for folks that are interested to get involved with our company and the market.
Thank you, Udi. Hi, everybody. I'm Sue Depositor. I'm the Director of People Operations here at Esperanto. Now that we've learned about the technical aspects of the company, why should you join Esperanto? Well, as mentioned, we're a key player in the AI space, so we're in the right place at the right time. So what's it like to work at Esperanto? What's our culture? We believe every person has an important role to the company, whether you be in marketing, engineering, admin, and so on. Our culture is based on teamwork, transparency, and trust. The experience and skills you will develop in a growing company will be a career booster for you. You will learn and be exposed to so much more. You will have ownership of your project and be able to see the final results of your work. In some cases, you may be involved in the planning stage, also known as clean sheet planning. Finally, your multifunctional communications with the various departments can drive your future management career, understanding the high level. Our corporate office is located in Mountain View, California. We have an engineering site in Portland and Barcelona and Belgrade, and a few people in Austin and London. Please visit our website often, as we are frequently adding new jobs. We also have a general mailbox in case you don't find a position that you're looking for. If you have any questions, feel free to reach out to Raj, Udi, or myself. You can see their email addresses on the slide there. We thank you for attending our job fair and learning about Esperanto. I would like to now open it up for questions. Which are the VLSI backend fronts Esperanto works in?
So we do have our own VLSI team internally. We have staff here in Mountain View. We have staff in Barcelona. We're actually looking to staff up also in Portland. We use a combination of resources. The internal team is actually responsible for the flow development, and also we have some very difficult pieces that are hard to converge. So we have internal staff for that, who takes care of kind of those difficult areas. But we also have outside partners that we've worked with in the past, and we're looking to work with again in the future, who will handle a lot of the sort of the final back end, and the actual tape out will probably be done by one of our outside partners, working very closely with them. But we definitely have room for very experienced block level and chip integration level and methodology expertise on the back end.
Okay, thanks, Raj. The next question, does the company have its own physical design methodology CAD flow?
Yes, we use industry standard tools, but we have a flow and methodology that we've developed internally for physical design.
What is the main purpose of Esperanto, software or hardware?
There are two things. It's always, ideally things start from the application and down, but it's never quite like that. The advantage that we have in our platform is that it's flexible. Software is, if you don't have a good software stack that is accessible to users that they can apply to their application, then you have a really nice piece of glass, but it's not very useful, or useful for a very particular purpose. So in that respect, so I'm not sure the main purpose, but definitely we put, I think Raj mentioned before, we put a lot of emphasis on hardware software co-design. There's always discussion, and both in the current generation and then over discussion for future generation. There's always, okay, here's what software think they need for this particular market. Okay, what can hardware do? And you go back and forth. So we strive for definitely this collaboration. So the intention is really to come up with a product that computationally is applicable to the or system that is applicable to the market and the product that we're targeting.
Thank you, Udi. From back-end physical construction perspective, is any specific tool set, synopsis, cadence, etc., expertise expected?
Yes, we do use synopsis tools mainly, but at past companies we've used cadence tools, and synopsis expertise wasn't too difficult to convert, and I think probably the other way is very similar. If you are an expert with cadence tools, it's not all that difficult to learn synopsis tools. It's not that much different. So we're open to both, but obviously what we use internally will be the synopsis tools.
Next question, how does the work from home and remote locations work in engineering?
Very well. We have I think both on architecture and VLSI and software, we have very distributed team. On the software side, we have folks in Serbia, in Barcelona we have a big team, a couple of people in Austin, including me. and some folks in Mountain View. We have a small team in Mountain View. There's some need to actually hands-on people in the lab, but that's relatively a small part on the software side. So in general, we definitely have very flexible work from home environment.
For the VLSI side, I would say, the world has changed, obviously, in the past, particularly in the past few years, but even before that, right, we see teams collaborating across geos and so on and so forth. So I think, we're doing more and more work from home, but it's actually not all that different from working with teams that are in different geos. So on the VLSI side, I think, there is a case for people being together in the room, right? And we've done a number of things like this where we might have an architectural brainstorm or something like that where we get people together. And then I think there are phases of the project where it's very valuable to have people together. So we do prefer some locality and ability to come into the office and have these brainstorm sessions. But most of the work we do, most days, people can work remotely without a problem.
Thank you, Raj. Question for Udi. Where could an engineer with past RTL design and application software background fit into your organization?
Well, we do have a need and folks working on low-level system. Coming from RTL, then that means you're not afraid of hardware. And now, of course, the rest of it depends on what other skills you bring to the table. That could be very helpful if you have also software skills that are any kind of firmware or embedded software that can help there. Then we definitely need help on that front. That kind of ties. So that's actually could be part of it. Could be depends where you're located. We actually on the low level software, we're actually looking for people both locally in Mountain View, but also some of it could be remote. So I'm not sure I answered the question, but that's primarily where I see that. Somebody with somebody who has exposure to hardware can fit in the software organization. Actually, we do have at least one person that I remember that it chose to transition from DV to our system software, and that happened relatively recently, and that's working very well. So that definitely is a possibility.
I'm a recent grad and interested in working at Esperanto in VLSI, physical design, and STA. What are the current opportunities at Esperanto at this level?
Yeah, so for VLSI physical design, we are actively hiring for block closure experts. So I think if you have expertise, more on the front end side of physical design, like synthesis, timing analysis, that's sort of what we're focused on right now. Some experience with that obviously would help. But we are actively recruiting in that area.
What kind of RTL development are you hiring in the U.S.? Is it the core or uncore? Is it from scratch, given you already have revenue?
Yeah, so in the U.S., we're looking for RTL is mainly integration and sort of IP integration, top-level integration, those sorts of things for RTL. We also have our big core, so we have a little bit of requirement for that as well. And as far as being from scratch, yeah, so we're essentially building on top of what we had in the first generation, but there are actually significant changes. We're making things, significantly better as far as power efficiency, overall performance. So I think there's actually very interesting work to be done, and then there are always new features that we want to add. There are many things that we didn't have in our first generation. And those features, I would say, are pretty much from scratch. So there's quite a bit of very interesting RTL work.
How many people in engineering?
I think total number is about 90. I think they're about, in my org, it was about 40. But most of the company is engineering. I think total number of companies, Sue, what did it? A little north of 100, like 102,
yeah.
3?
Yes, so we have a total of 102 worldwide.
Yeah, most of that is engineering.
Are DevOps role part of UDI's organization or VLSI?
Yes, in my organization.
Yeah, so we have somewhat DevOps going on in VLSI as well. We use continuous integration with Git. So there's a little bit of a role there, but it's part of our design verification. So we use design verification specialists to handle that.
So thank you everybody for attending the job fair. Again, if you have any questions you want to direct to Raj or Udi or myself, you can see our email addresses on the slide. And again, thank you very much. We appreciate it.